So you can put this also on page 667 or on page 666. There's lots of room there too, so if you wanted to start it there wherever you have more space. This is looking at if I have a solve question and I have a 2x, either sine 2x or cos 2x, how do I know when it's a multi-revolution question? Because that 2x makes me think of multi-revolution, but now the 2x is also making me think of my identities, and so I have to make a decision what strategy I'm going to use. Sometimes you learn more stuff, just makes the previous stuff you learned before harder because it gives you more options. This is one of those cases. So you can solve it as a multi-revolution question if the only function you have is that 2x function. So I've got an example here. Cos 2x minus root 3 over 2 equals 0. The only trig function I have is cos 2x. So then I can isolate that and solve it as a multi-revolution question. I'll use my double angle identities if I have that double angle and another trig function. So the example there, I have a sine 2x and I have a sine x. So I'm not only having one trig function. So let's do the cos 2x one first. This is a double angle one because our only function is the cos 2x. So we're going to think, well, if x is between 0 and 2 pi, then 2x's would be between 0 and 4 pi, which is twice around. It is on our pi plate. When do we get root 3 over 2 for cos? Pi over 6 in quadrant 1. 11 pi over 6 for quadrant 2. Negative pi over 6 is right, but it's not between 0 and 4 pi. So we're trying to solve between 0 and 4 pi. Quadrant 1 and quadrant 4. That's our first time around. Second time around, we'd add 2 pi. Of course, adding 2 pi is the same as adding 12 pi over 6. So add 12 pi over 6 to the first one, you get 13 pi over 6. Add 12 pi over 6 to the second one, you get 23 pi over 6. Divide them all by 2, and we get pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. So that's a double angle one, and we've solved it between 0 and 2 pi. The second question, on the right, we have sine 2x equals sine x. We do have our double angle and another trig function. So in this case, we're going to change this to 2 sine x cos x, because that's what sine 2x is equal to. We still have sine and cos. This is where you're going to be tempted, again, to divide both sides by sine. But if you look at it, you can see that sine equals 0 is one of our solutions. So we're going to make, instead, one side equal to 0 by subtracting sine x on both sides, then factoring out the common factor of sine x. And we get sine x is equal to 0, or cos x is equal to a half. When is sine x equal to 0? 0 pi and 2 pi. When is cos x equal to a half? Pi over 3 in quadrant 1. And 5 pi over 3 in quadrant 4. Now, on the back of that identities sheet, where you had all the proofs on the first side, there is a number of questions that are good for practice. You'll notice the first ones, I think, are calculator ones. Does it say solve between 0 and 360? The first ones are actually in degrees, and the second ones are in radians. You have to decide whether the value is on your pie plate or not. So some of them will be calculator and some of them will be exact values. And the ones that I would tell you to do for practice, 8, 9, 11, 12, 14, 15, 21. No, don't do them all. 21, 27, 29, and 31. So that's on the back of that handout sheet that we had before.